Okay, last little bit of this problem solving and reasoning section. Okay, so I've got Ryan notices that b4 to the power of 2 times b4 over b squared to the power of 6 all equals 1 regardless of the value of, now that should be b. I've realised that typo. Okay, so this all has a value of 1. It doesn't matter what b equals. Okay, it says simplify to prove this expression. So let's have a look. I'll rewrite it. b4 squared times b4 over b squared 6. Okay, so this is index law 3. It says to simplify it, to prove it. 4 times 2 is 8 because of index law 3 times b4 over, okay, 2 times 6 is b to the power of 12. Let's finish off our simplifying. 8 plus 4, index law 1. 8 plus 4 is 12 over b12. Now that equals 1 because anything divided by itself gives 1. Let's take away the b's and just pretend it's 12 divided by 12. 12 divided by 12 is 1. 10 divided by 10 is 1. Anything divided by itself is going to give you a value of 1. Okay, anything divided by itself is going to give you a value of 1. 1,000 divided by 1,000 gives 1. Okay, create your own. So you could go C, and I'm envisaging that the numerator is going to have a value of C24. Okay, so I'm copying this idea to a point. Let's even make it 6 to the power of 4 and then 6. Okay, because then that means my denominator has the 6 to the 24 because I've kept the base and I've multiplied the powers. Let's work on something at the top here. 6 in brackets. 6 squared. Okay, sorry, c squared. Now I know I want the top to have a value of 24. I might make this a 3 and make that a 7. And then I might make that a cubed. Okay, so now I've got c, keep the base, multiply the powers, c21 that will be for index law 3 times c3. Okay, so my c24 was worked out earlier for the denominator. Now if I keep the base and add these indices for index law 1, I end up with c24 at the top, c24 at the bottom. Okay, this one here, explain the connection between expanding and factorizing. So I guess we've worked on the idea of different form, same value. Okay, different form, same value. So if you have a factorized version, it could be something like 3x plus 2. Okay, this is factorized. Okay, your expanded version of that is going to be 3x plus 6. So that's the idea of showing that they're a different form. Okay, they look different. This is the factorized form, this is the expanded form. Yes, they look different. However, they have the same value. So let's come down to the bottom of the page and say x, for our question, x is going to have a value of 4. So if we take our factorized version, it's 3x plus 2. Which leads us to saying, well, 3 times 4 plus 2, because we're putting in our value. That's going to be 3 times 4 plus 2 is 8. 8 threes are 24 as our answer. So our answer is 24 with the factorized version if we give x a value of 4. Okay, now if we choose this, 3x plus 6, which is our expanded version. We're hoping to get the same value. So that's really 3 times x, which is 3 times 4, okay, plus 6. 3 4s. So look what I've done over here. 3 4s are 12, plus 6 equals 18. Right, I've realised my mistake. Over here, it's 4 plus 2. Okay, 4 plus 2 is 6. 6 3s are 18. So what we're saying is that they're the different forms. They look very different. They're worth the same value if the variable is kept the same as 4. Okay, as I stretch this out, I put in 3 multiplied by 4 plus 2, because our x is 4. 3 times, okay, 6 was my mistake, because I did, 4 plus 2 equals 6. I had to put 8 there. 3 times 2, 4 plus 2 is 6, so 6 times 3 is 18. Over here, substitute in my 4. 3 times 4 is 12, plus 6 gives me 18. So that's your way of explaining it, okay? This could be your description, but explain it using an example. Okay, keep your examples really simple with small numbers and not a lot of variables. Substitute in a value, and that can prove and explain that they are different forms. They look different, but when you give the variable a value, they both end up with the same answer. Okay. All right, choosing one of these to explain. I might just get a quick spare bit of paper, sorry. I'm going to explain index law 1, for example. It says choose one of the index laws or x to the power of 0, because that's not an index law, that's just an extra rule, and explain why the law works, giving proof. So if I go with index law 1 and I look at something like m to the power of 3 times m to the power of 2, okay, you're not just wanting to solve that, you're wanting to prove it. So it's m times m times m times m times m. Okay, so this is your m cubed, this is your m squared, and you say how many m's do I have? 1 2 3 4 5. Okay, but why would you want to write this out every time? That's why we say 3 plus 2. Okay, so you could prove it with a really simple question and explaining that you understand the rule with this type of step. Thank you.